it's really easy to think that the ice you have is okay because you're not aware of any handling changes or behavioral changes in the airplane. And you won't be necessarily until you get to that critical angle of attack. And that varies depending on the ice shape and how much you have and so on and so forth. That's what makes it a real threat.
Can you take me through what kind of currently happens as far as this from the passengers' perspective?
Sure.
Like goop is flying out the window. That's what we see. Can you tell me from a pilot's perspective what's actually happening here?
So the idea there is we've got snow falling or freezing precipitation of some type is falling. It's adhering to the wing. So it's creating a layer of ice, and we can't have that. And we typically do this in a two-step process. We use what we call type 1 fluid to remove the snow and ice that's on the wing. And then we apply a type 4 fluid, which is a very thick fluid that creates a layer that sits on the wing. And the idea behind this is it absorbs falling precipitation during the time the airplane is outside before it takes off. So we have what we call a holdover time, which is in these conditions at this temperature, how long is this fluid going to be good for? And we've got all that data in the cockpit. So we know what time we were de-iced. The de-ice administrator on the ground is going to talk to us and say, we completed this application at this and this time, and we start the clocks and so forth. So then what happens is when we get out to take off, as we accelerate down the runway, that fluid shears off the top of the wing. And it works really well as long as you stay within those holdover times. And this is where, you'll have, long lines for departure. And sometimes passengers will experience this where they think they're about ready to go. And then the captain has to come on and say, sorry, folks, but we've exceeded the holdover time for the de-icing. We got to go back and do it again. And, those nights get ugly.